Hello, Didier Stevens here, analyst at Enviso. In our series of videos on decrypting Cobalt strike traffic, we are now looking at to decrypt DNS traffic on our blog post number 5 that is explained in detail. And here in this video number 4, we are going to show you this. So we have a process memory dump of a beacon that uses DNS to communicate. So not HTTP or HTTPS, but DNS. With tool 1768, we can also analyze process memory dumps, and here it extracts the configuration of the beacon. And if we look at the payload type, we see that it is a beacon DNS reverse HTTP. This means that this is a beacon that is capable of to communicate over DNS, and if it is just a shellcode stage or shellcode, it is also capable of downloading the full beacon over HTTP. But this beacon here is already a full beacon, so it will do the decoding over the communication over DNS, port 53. This is the domain. And then what is important here for parameters when it comes to DNS beacons are these values here. DNS idle, that's an important value. You see, it's an IPv4 address 8844. By default, that is 0000. That is what the team server replies. It also acts as a DNS server at that moment, its listener. So this is what the team server replies when there's nothing to do. So by default it would be 00000, but here it is configured to be 8844, and so one of the known DNS servers from Google. When you see this as a reply, then there is nothing to do. We can see that here in the capture traffic that I filtered on DNS. You see here requests for walletsthedarkside.org, and here those return values means that there is nothing to do. And then for the different methods to communicate, what prefixes are used in the host names. So to decrypt this, here we have, for example, here on this request you see that the answer is not 8844 but 88452. So that means that there is some data, and this data here has to be transferred via text records, as you can see here, and inside that text record you have some base 64. So we will extract this using tool CS parse traffic. So this time, since it's not HTTP or HTTPS, we have to tell the tool that. So with option S, the format is DNS. We also have to tell it the idle value, if that is different from 0000, and here it is. So we have to provide that, and then we can say that we don't know the key. We give it a capture file, and then it will search through all the DNS requests and extract the encrypted data for us. Of course, there is a lot more here, because over DNS that's a low bandwidth channel, so a lot of requests to transfer data. Okay, and here, for example, we see a post. So this is with the post prefix, and this is the posted data. So this is a callback, and then we can use that callback, that encrypted data, to try to recover the keys from process memory. So CS extract key. Now in previous videos we worked with tasks, so I had to use option T. Here we have a callback, so you should in theory work with option C, But there's something special with DNS traffic, and that is that a callback in DNS traffic is slightly different. The format is slightly different from a callback in HTTP or HTTPS. Actually, a callback in DNS is the same format as a task in HTTP. So if we would run this on the capture, we get an error because it doesn't look like callback data. And that is because there is no prefix here of 4 bytes that specify the length. That is the format, and that is something that is not present in DNS. So when it is DNS, we always have to say that it is a task. And then it starts to look for keys, and here it found a yes and HMAC key. So this is the key we can use to decrypt the traffic. Found the position here, more positions. Even more positions where it found keys. Okay, and here we are. And so we can now go back to our command here, where we recovered the encrypted data by specifying key unknown, and now we are going to specify the key like this, and like we did in previous examples, but here for DNS, and now the DNS traffic can be decrypted. Okay, here is an overview of the commands that were found. Change directory, print working directory, list files and execute jobs, and here the callbacks for the current directory for pending and just output. And if we scroll back here, we see output what looks like name of workstation. Here also, scrolling back more, and here we can see a command to execute a job, here a PowerShell command. So with the same tools we can also decrypt DNS traffic, but we have to use slightly different options and formats because it is DNS traffic.